Hello everyone, welcome back to my channel SOCWatchTower and SOC Analyst series. So in today's video we are breaking down NAT and PAT. These are the two core networking concepts every SOC analyst must understand. So if you ever seen private IP addresses in the logs or in the firewall alerts or in SIM events and wondered how they actually communicate with the internet, this particular video is for you. So by the end of this session, you will understand what NAT and PAT is, how they actually work, static NAT and dynamic NAT, and the visually flow of NAT and PAT. So, without wasting our time, let's get started and we'll move to our first slide, that is NAT. So, what does NAT is? So, NAT basically stands for Network Address Translation. Okay, so it is basically a technique the used by the routers and firewalls to translate the private IP addresses into public IP addresses. Okay, so it is basically a technique used by the router and the firewall to translate the private IP addresses into public IP addresses before sending traffic to the internet. So I'll give you an example. For example, private IP ranges. Let's consider 10.10.0.0.8 192.168.0.0. Okay, so for example, this is a private IP ranges. So these IPs cannot communicate over the internet directly. Why? These are the private IP addresses. So so NAT basically act as a translator between internal private network and external public internet. Okay, so whenever we have to communicate with the internet, private IP addresses cannot directly go and communicate with the internet. So in that situation, that particular IP addresses which is being assigned to any of the devices is being converted into public IP addresses by the router to communicate over the internet. Okay, so why NAT is actually required? Okay, why do we need NAT? Okay, so first is private IP addresses cannot access the internet directly. For that private IP addresses is being converted into public IP addresses to communicate over the internet. Second thing is second thing is because of IPv4 address shortage. So there aren't enough public IP addresses for every device in the world. So what does NAT do is NAT allows hundred of devices to share one or few public IPs. Okay, this is the first reason. This is the second reason. Third, we can consider in terms of security. This is just basic. So NAT hides internal IP addresses from outside world. Okay, so because of this, attacker won't be able to see your internal IP addresses. Instead of that, he will only see the public IP and not your internal structure. Okay, so there is one important point as an SOC analyst which you have to remember, that is NAT is NAT is not a NAT is not a firewall. It provides hiding, that is hiding of your internal IP addresses. Okay, but this is not a full security. This is the main point which you have to remember, is NAT is not a firewall. Okay, moving to the types of NAT. So basically there are two types of NAT, that is static NAT and dynamic NAT. So static NAT is basically, we can say it as 1 to 1. Why? Static maps one private IP to one public IP. So for example 192.168.1.10. So this is basically a private IP which is being assigned to 203.0.113.10. So this is the public IP addresses. Okay, so one private IP address is assigned to only one public IP. So these type of NAT is basically used by web servers and mail servers. Okay, mapping is fixed. It means one IP address is being assigned to only one public IP. Okay, after that, second is dynamic NAT. So dynamic NAT basically uses pool of public IPs. So I'll give you an example. Let's take it. Let's take private IP 192.168.1.10, 192.168.1. Okay, let's take public IP, two public IP, 203.0.113. And 203.0.113.11. Okay, so router can assign any of the available public IP temporarily to any of the private IP addresses which are being there. Okay, so mapping changes dynamically. This that means it's temporary. Like the public IP which is being assigned to any of the private IP is temporary. Okay, it uses, as already discussed, uses pool of public IP addresses. So if the public IPs in the pool runs out, then the new session will fail. Okay, that was about static NAT, dynamic NAT, why NAT is actually required. Okay, now we'll move to our next slide and we'll try to understand how NAT actually works. Okay, so we have, let's take an example, internal PC which is being assigned a private IP, that is 192.168.1.10, and public IP of a router, that is 203.0.113.5. Okay, so when users visits google.com. Okay, so what's going to happen is, in the first step, this is particularly source IP, that is the private IP address, which is being assigned to the public IP, which is being assigned to the PC, sorry, and destination IP, that is your Google IP. Okay, so in the second step, what router do is router replaces source IP, which is this, with 203.0.113.3. That is your public IP, which is being assigned by a router. Okay, and all this happens inside a NAT table. Okay, so this this translation is stored in NAT table. Okay, so internal IP internal IP is this one, which is being assigned to the PC. Public IP of a router is this one. So whenever you are going to type any of the website, so in this case google.com, the source IP is 192 and destination is Google IP. So what router does is router replaces this public IP, this private IP, with the public IP, so that your PC can communicate over the internet. Okay, so that's how actually NAT works. So I'll give you a flowchart explanation. Okay, so let's consider internal device. Okay, a router receives the packet, in this case google.com. It will check the NAT NAT table. Okay, so there are two situations. If entry exists in the NAT table, it will check for yes or no. If no, it will close, and if it yes, it will translate or create new NAT entry. So sorry, this will not close the session. That's my mistake. Yeah, two situation. If the entry exists, it will check whether yes or no. If the entry exists, it will translate, and if the entry doesn't exist in the NAT table, it will create a new entry in the NAT table. After that, it will replace the source IP with public IP with public IP, and it will forward to internet. Okay, so this is the visual chart of how actually NAT works, and this is the example. Whenever you type google.com or whenever you visit any of the public website, in this situation, how NAT actually work. Okay, so now we'll move to our next slide, and we're going to understand what is PAT. Okay, so like NAT, we have another topic, that is PAT, and PAT actually stand for port address translation. Okay, it is also called as NAT overload. Okay, so this is the most commonly used NAT type in home and the enterprises. Okay, so what it does is instead of using multiple public IP, PAT uses one public IP with different port number. Why? To support multiple devices simultaneously. Okay, so it is a type of NAT where multiple private IPs share a single public IP using a port number. Okay, so why PAT is actually required is allow many devices to use the internet using one public IP address. Okay, so for example, you are in a home and you have multiple devices like you have laptop, you have iPad, or you have an iPhone which is being connected to a single router. Okay, so all the devices which are being connected to that particular router, mostly most of them will be having the same private IP addresses. Okay, remember that. So I have given a layman example. So think of a public IP as school address and port number as a student roll number. So mail comes to the same address, but it delivered to the correct student. Okay. Now we'll move to working of PAT. Okay. So how actually PAT work? So let's take an example. There are two PC. Okay. One PC is being assigned with this public private IP address, and the other one is assigned with this private IP address, and we have a public IP that is 203.0.113.5. Okay, so both the devices open the Google or google.com or any other website at, remember this, at same time. Okay, so how Pat is going to assign the public IP? Okay, or else we can say how these two devices are going to share one public IP. Okay, so let's say there is a PAT table like NAT table. Okay, in that these two devices private IP addresses are being assigned with the port number. Okay, so in the PAT table, how it's going to happen is both of these unique private IP addresses are going to assigned with a same public IP addresses but with different port number. Okay, so if you see, this is the private IP address of PC1 and this is the private IP address of PC2. They both are having the different port number, but after PAT, these two are being assigned with the same public IP but with the different port number. Okay, So instead of using two different two different public IPs, in this case only one public IP is being used. So that means one usage of one public IP address is being saved. Okay, got the point? So I'll give you a note. So same public IP, just remember the same public IP but different source port. Got it? Okay. So yeah, so both of the PC, both of the PC wanted to connect to google.com or any other website at the same time. In the PAT table, both of the public IP, private IP addresses are there, and both of the different IP addresses are being assigned with a same public IP with the different port number. Okay, so when the responses come back from the google.com, how Google will understand where to respond or to which particular PC to respond, whether it's PC1 or PC2. Okay, so in that scenario, let's say this is the public IP addresses of both the PC1 and PC2 with different port number, and as it is being assigned with the port number, the website is going to understand to which particular computer the data needs to be sent. So if you see this is being assigned with this public private IP, that is 192.162.1.10, and the other one is being assigned with 192.168.1.11. Okay, so that's how router actually differentiate between the sessions. Got it? Yeah, so now we'll try to understand the same flowchart. Yeah, so we'll check this via flowchart. So for example, there is a internal device. Okay, packet is sent with packet is sent with source IP plus source port. Packet is received by router. It will create a pad table like NAT table, uh, which we saw in our previous slide. In that, private IP will be assigned with a port that will be translated into public IP with a new port, which will replace the source IP and the source port, and it will send the data or send the packet to internet. Okay, so that's how actually PAT work. Okay, so let's see, this is the PC1 IP addresses, PC1 address. This is PC2. Okay, both the IP addresses are there in the, this is PAT table. Okay, the first private IP address is being assigned with the source port, and the second PC private IP address is being assigned with the port. And in the PAT table, it will be converted, and it will be translated and will be assigned with the same public IP but with different port numbers. Okay, got the point. So that's how actually PAT work. So let's have a quick comparison between NAT, that is network address translation, and PAT, that is port address translation. So let's have a feature NAT and PAT. Okay, so NAT basically stand for, as already discussed, network address translation. Port address translation. How mapping is done? Mapping is done IP to IP. One private IP is being assigned to one public IP. Here IP plus port. So IP, same public IP, same public IP assigned to multiple devices but with different port number. Okay. Public IP usage, that is multiple in NAT, and in PAT usually one, which is being assigned to multiple devices. It is used in NAT is basically used in servers, and PAT is used in home or enterprise internet. It is also called as basic NAT, that is basic network address translation, and PAT is also called as NAT overload. Okay, so this is the basic comparison between NAT and PAT. Okay, so if we see in the SOC analyst perspective, why NAT and PAT actually matters to SOC analyst. Okay, we there are few points which we have to consider being a SOC analyst while dealing with NAT or PAT. So you have to always remember that log may show public IP instead of real real internal IP of a device. Second is, you must check firewall NAT tables during investigation of any incidents, or whenever you are checking any logs. Okay, IR, that is incident response, basically requires NAT correlation for their investigation purposes. And One more is threat hunting behind NAT requires mapping. Okay, so let's try to understand this with an example. So we, for example, we have a attack in which we are actually investigating, and we have a sim log which basically shows that attack is coming from a IP that is 203.0.113.5. Remember, this is a public IP. Okay, but which internal device? But which is the internal device? Which is the internal device? We are not sure. Why? Because the sim log has not shown the private IP addresses of any of the devices. It is being reflected a public IP. Okay, so what you can do is you must check the NAT log, basically check NAT logs. You can match the, I would say, match the timestamp. You can match the port number as well, with port number, and I would say you can check, identify the real internal IP. Okay, so that was the topic which we wanted to cover today, that is NAT or PAT. So today basically we try to learn about what NAT and PAT is, why it is actually required, the the two types of NAT, that is static and dynamic, the NAT and the PAT flow, in a flow chart way we try to understand, and how actually NAT and PAT works, and what is the uh, SOC relevance related to PAT or NAT. Okay, so this was the end of this particular video. So in the next video, we will be covering commonly used port numbers that are very important, which is extremely, I would say, important in SOC monitoring and threat detection. So if you found this video helpful, please like, share, and subscribe to continue mastering networking fundamental for SOC analyst. So see you in the next video. Thank you, everyone.